Number 2. See, we'll be dealing with this one to say calculate the molecular mass of a compound, relative molecular mass of a compound, sodium triisocarbonate 4 decahydrate. Sodium triisocarbonate 4 decahydrate. First of all, we write the chemical equation, that will write the chemical formula of sodium tetraisocarbonate 4 decahydrate. This is sodium, this is triisocarbonate, and then decahydrate. Decahydrate is 10 water decahydrate. Now, first of all, we're given the mass of this element, relative molecular mass of the individual element. Sodium has 23, carbon has 12, oxygen has 16, and then hydrogen has 1. Now, first of all, we now separate them by the number of their contribution in the equation. First of all, sodium has 2, that's 2 times 23. Carbon has 12, that is 12, and then oxygen has 3 times 16, and then decahydrate is, this is 2, this is 16, that is 2 plus 16 is 2 plus 16 times 10, because the 10 is for both hydrogen and then oxygen. The 10 is for both hydrogen and oxygen. Okay, first of all, after multiplying out using your calculator, 2 times 3, that is 46. 2 times 3 is what? 46. And then 12. We'll plus it by 12 and we'll plus 48. That is this one plus 180. The answer is equals to 286. So this is how to solve the relative molecular mass. Let's go to even more examples. This one says calculate the relative molecular mass of the following compound: copper 1 tetraoxosulfate 6, copper 1 tetraoxosulfate 6, copper 1 tetraoxosulfate 6. So we are given the formula, the relative atomic formula of copper. We have copper 64, 32, and 16. That is copper 2 tetraoxosulfate. This is the constituent element. This is the constituent element of copper 1 tetraoxosulfate 6. Look at it, copper 1 tetraoxosulfate 6. Now the solution is copper will have 64. Copper is what? 64. That is why we have 64 here. We'll have sulfur here, that is 32, and that is why we'll have 32 here. And then we'll have oxygen, that is what? 16. That is 4 times 16. That is what? 4 times what? 16. So this is 64 plus 32 plus 16, which is equals to 160. So this is how to solve it. And then the next one is calculate the relative molecular mass of the following compound: tetraoxophosphate 5 acid, tetraoxophosphate 5 acid, that's H3PO4, H3PO4. That's we have a video. We'll have a video where we taught how this thing can react, how the oxidation and the reduction number can react, and then how it becomes neutral, and how what you're going to do to it to become ionic. Or so for here it is still very neutral. So this is P equals to 31. That's P is equals to 31. That's phosphorus. It has a mass of 31. Hydrogen has a mass of 1, and oxygen has the mass of 16. Now the mass of this element, because it is measured with the mass spectrometer, it is always constant. The mass of this element is always very constant. And then this is the solution: H3, that is 3 times 1, and then we have P, that's 31 plus O4, 4 times 16, which is equals to 3 plus 31 plus 64, which is equals to 98. So this is how you calculate the relative molecular mass of an element. Let's go back to what we did. We did the relative molecular mass of this element. We calculated the sodium triisocarbonate 5, sodium triisocarbonate 4 decahydrate. We calculated it, and then look at the relative molecular mass. Then this one is calcium copper 1 tetraoxosulfate 6, and then look at how we calculated it: copper 1 tetraoxosulfate 6. And then the next one we did was tetraoxophosphate 5 acid, that's hydrogen tetraoxophosphate 5 acid, and look at how we calculated it. So let's move on. In our next class, we are going to also solve more examples with this, and then we'll be talking about getting into percentage composition of different elements. Hope you enjoy this class, and then In case you've not subscribed, you should like and then subscribe our page for more. If you have any other question, if you have something you would want me to address, you can talk to me in the comment section. Thank you.